Hi everyone, so today I'm going to discuss about continuous functions and limits at infinity. So first let's see what is the continuity. So to discuss about the continuity we need to first understand about the limit. If the limit exists then we can discuss about the continuity. If at that point it doesn't contain any limit then we can consider about continuity. So especially when we are discussing about continuity, here I discuss about pointwise. It means I consider some specific point C, then I discuss about the continuity at that point. To exist the continuity at that point, it must contains three conditions. First one is this one. The value of the limit must exist at that point. It means fc must a defined value. Second thing is when x goes to c, fx, the limit of fx at c must exist, and third one is these both values must be equal. So then we can say at the point c it contains continuity. So basically if I discuss our using our day-to-day life, this is a continuous line and this is a discrete line. So for such a discrete line we call it as not continuous. So you can see these dashed lines in spaces, it is not continuous, but this line it is continuous. This is the main difference. So in mathematically by using this phenomena we can check at the continuity at a given point. Okay, so these are some three basic examples to discuss about the continuity of some given graphs. So let's look at part A. So if you go to part A you can find at the point 2, if we check limit, so we have to consider it by our right hand limit and left hand limit. First consider left hand limit. You can see function goes to infinity when x arrives to 2, and when x arrives to 2 from our left side negative side functions goes to negative infinity. So definitely we can say at that point it doesn't contain a limit. So if it doesn't contain any limit we can discuss about a continuity at that point too. Okay, now let's move to our part B. So if we look at the part B, clearly you can see when x is equal to 2 in here, this point doesn't contain any value, so f2 does not exist. So if the value of that function at that point 2 doesn't exist, means limit doesn't exist. Now let's go to our third example, C. So in C you can clearly see our left limit and right limit is equal, it becomes 2, and the value of the function at 2 is equal to 4. Limit exists and the value of the function at that point 2 exists, but the problem is they are not equal. Then we can say this function is not continuous at 2. So these are some basic examples to discuss about continuity. So when we are discussing about polynomial and rational functions, polynomial function is always continuous, and rational functions especially we have to consider numerator and denominator separately. So if both numerator and denominator exist and they have non-zero values, then definitely we can say that function is continuous. And otherwise if the fx for the numerator is doesn't equal to, if it is equal to 0 but gx doesn't equal 0, then that time also function has a continuity. So this is example about piecewise function. Speciality in here is we need to first understand a critical point. So what is our critical point? So clearly you can see -1 is the critical point. Now this function has two pieces. When x is greater than -1 it is 3, it's like a constant, and when x is less than or equal to -1 functions behaves like this way. So first you need to find left limit and right limit. So when we are finding our left limit, x is arriving to 1 from negative side, it is become 2. So our negative limit, left limit is 2, and our right limit when x arrives to 1 from positive side, from x arrives to -1 from positive side, it is 3. So now we can say our left limit and right limit doesn't equal, so limit doesn't exist at point -1. So if limit doesn't exist, it means this function is not continuous at -1. So this is the given result. In graphical you can see it clearly. And if we go to second part, when x arrives to 2 from negative side it becomes 0, and when x arrives to 2 from positive side it becomes 0, then we can say limit exists at 2, it is equal to 0. And now let's need to find the value of the function. It is also 0, so value of the function is equal to limit, then we can say limit exists at 2. So this is the basic idea how we can find the limit of a given function at some point. So first we need to check whether the value of the function exists at that point, and secondly we need to find the limit of the function at that point, and for the third condition we need to check whether the limit and the value of the function at that point is equal. If these three happen, then we can say the function is continuous at that point. Now let's discuss about limits at infinity. So in here the speciality is when x arrives to positive infinity, if we consider constant, it is constant, and then for the negative case also, if x arrives to negative infinity, when we are finding a limit of a constant is constant. But here, if we divide constant by a power of positive power of x, when x arrives to infinity, positive infinity is 0, and when x arrives to negative infinity also it is 0. So these four are very important to find a limit at infinity. Now let's look at some example. From here you can see, now let's discuss about part A. In part A, in these problems, always memorize very carefully, we need to divide all terms by the highest power of x. So here the highest power of x is x to the power 1. So I divide both numerator and denominator by x to the power 1. So this is our final solution. Then take the limit. So here this 2 is a constant independent of x, so it is 2, and 1 is independent of x, it is 1. This goes to 0 because it is 1 over x, and this goes to 0 as x goes to infinity. So finally our result becomes 2. And then let's move to our next section. It is x square plus 3 divided by 1 minus x. So here also first we need to understand what is the highest term. So highest term is x to the power 2. I divide both terms by x to the power 2. Then finally we can get this one. Here 1 is a constant, it is independent of x, it is 1, and here 3 over x square, what is the value? It is 0, because x arrives to 0, this goes to 0, and this goes to 0, and this also goes to 0. So finally we can take 1 divided by 0, it is infinity. Then we can say limit doesn't exist at that point. So thank you everyone, and let's meet on next day.